As we finish topic 6, advanced hypothesis testing, we will be looking at lastly variance comparisons, and we will be using again high school student performance data across multiple schools. And we got that data from the UCI Machine Learning Repository, and we imported the data, created the data frames that we'll need, and imported the modules that we will be using and set the significance level to 0.05. So as we venture down to variance comparison analysis, the problem we will be looking at is the data contains grades from both male and female students. So is there a statistically significant variability in the students' final grades based on gender? The data we'll be looking at is the variable of sex, which is a string for male or female represented by M and F, and the final grade, which is G3, an integer. The research question is, are the variances of male and female final grades equal? So the hypothesis, the null hypothesis is the variance 1 equals variance 2, which is male variance versus female variance. And variance 2 is not equal to variance 1 as the alternative hypothesis. So the statistical test we will be using will be the Levine's test to test for equal variance or homoscedasticity. And the assumption is that there is normality, but that does not necessarily affect the Levine test because it works for both normal and non-normal data sets. As we use Python as a tool, again, we can use it for writing scripts to check for homoscedasticity. It gets me every time, or equal variance. So for example, if P is less than alpha, then it would print out reject the null hypothesis, else we would fail to reject the null hypothesis. And we can also use it for data visualization, creating a box plot to visually support the data. And we can see the spread of the data. So wider boxes indicate a greater variance, the median comparison, as well as outliers. So as we split the data into groups by gender, we run the Levine test for male variance of grades versus female grades variance, and we get the p-value is greater than the significance level of 0.05, so we fail to reject the null hypothesis. There is no significant difference in the variance of their final grades based on gender. So as we look at this box plot visualization, we can see that it is very similar in shape and size. The medians are close. The male students do have some outliers. However, there isn't statistical significance within the variance of the gender's final grades.